Angle of a prism is A. One of its refracting surfaces is silvered. Light rays falling at an angle of incidence 2A on the first surface returns back through the same path after suffering reflection at the silvered surface. The refractive index mu of the prism is A 2 sin A, B half cos A, C 2 cos A, and D tan A. We have a prism with angle A and one of its surface is silvered. Now we have the incidence ray which is at an angle 2A on the first surface. And at the first surface refraction takes place, and since it is traveling from a rarer to denser, the refracted ray moves towards the normal. And we are given that upon meeting the second surface which is silvered, which acts as a mirror now, it returns back to the same path. That means after reflection it returns back to the same path. We know a law of reflection is that angle of incidence is equal to angle of reflection. Here if it comes to the same path, that means there is no angle of incidence, there is no angle of reflection. That means it is traveling along the normal to the surface. So here we have 90 degree and it travels back to the same path. Now we have to find the value of r. We can from the figure we can identify a triangle over here, and we know two angles, one is 90 degree and one is A, and we know sum of angles in a triangle is equal to 180 degree. So this angle would be 180 minus 90 plus A, which is 90 minus A degree. We have another right angle over here, this place, and we know a portion of it is 90 minus A, so it means R will be equal to A. Now what all are the information we can get from till now? Till now we have angle of incidence 2A, then we have angle of refraction A. Since the other medium is air, mu 1 is equal to 1 and mu 2 is what we have to find. That is mu is what we have to find. Now we can use Snell's law. We know Snell's law is sin I by sin R is equal to mu 2 by mu 1. So with the values we have, we can write sin 2A equal to mu 2 is mu sin A, and we know sin 2A is 2 sin A cos A, so we have 2 sin A cos A equal to mu sin A. We can cancel sin A on both sides. We get mu is equal to 2 cos A, which is our option C.